first, Shireesh, I'd love for you to tell the listeners about yourself.
Yeah, thank you. Sure. So, corporate vice president for Azure databases. So, what it means is that I have the remit to manage all operational OLTP databases for Microsoft. This includes on-premises instances like SQL Server, obviously. We have IaaS offerings for SQL Server and a couple other databases, but primarily the PaaS offerings in Azure SQL, Azure Cosmos DB, which is a very differentiated non-relational database, and then the OSS databases, both Azure Postgres as well as Azure MySQL. And we've recently shipped the database into Fabric as well, so SaaS. So all the way from on-premises to IaaS to PaaS to SaaS, anything related to operational databases is kind of under my remit. And if you want me to talk a little bit about the career, that I could just go in just a few bits here. It's been a long journey through the evolution of databases, I would say. I started out working on SQL Server primarily. That's kind of really where I learned the fundamentals of OLTP systems. I worked on various aspects of SQL Server, shipped a bunch of releases back in the day. And it also helped me learn the craft of building software. It was sort of my formation years. And then I moved on to being one of the founding members of Cosmos DB. That was a complete shift in mindset, going from a single node, high reliability systems to kind of thinking about globally distributed, elastic kind of databases. And it's also non-relational, so there's no schema there. And it kind of taught the distributed systems consistency challenges, scalability, internet scale, user-facing applications, and it's kind of a different muscle. Along the way, I also took a small detour to join SingleStore. It's a great company, which basically was focusing on real-time analytics, sort of really challenging the transactional analytical boundaries with a very novel architecture. And that experience was valuable because it kind of forced me to think about speed, agility, living closer to customers, and deeply thinking about performance at scale and such things. And now I have the privilege of effectively leading the database portfolio that I was mentioning a minute ago. And I think in a way, I find myself privileged and grateful that I got a chance to experience different kinds of these experiences across the board, from SQL to Cosmos to SingleStore, and then back to all. And then now I'm focusing quite a bit on all these databases as well as open source, Postgres in particular. And it kind of really puts all of these things into the context of Azure's broader mission. So yeah, that's kind of like my the through line in my journey is that I've kind of really been drawn to the challenge of developers, enterprises, systems, etc. So that's kind of really who I am, and I enjoy what I do.
Yeah, incredible to hear just the both depth in which you've went into database systems as an engineer, and also the breadth of the different types of systems you've worked on, which is, I think, incredibly valuable, especially as these workloads are evolving so much and the requirements are now being completely transformed by AI. We'll get into that. Alok, this is your second time on this show, and you also have a very deep database background. Would love to hear about that as well.
Yeah, thanks, John. And Shireesh, very impressed. And the journey is kind of remarkably parallel, I would say, right? The formation years and the foundation years. I got to be part of the Oracle database and kind of grew up there. Got to work on a lot of interesting features. This is my second time, John, on your show. So hopefully you'll invite me again, and we'll make this one of those Saturday Night Live. I'm hoping to get a robe from you as well. SNL 5 or maybe JK 5 or something like that, and hopefully Shireesh will be back as well. So I said, I started off in the Oracle database, and I've taken an interesting journey all the way till Striim, where I am right now. So I'm one of the co-founders in Striim. I run all of the product areas here, right from engineering to product management to product support, documentation. All of the product aspects come under me, so I really enjoy doing that. And then also, it's a great place to be. On one hand, we are working with some of the leading global large enterprise customers. So one day, I find myself in a conversation, with some of the largest banks in the world, trying to look at some AI use cases. And the next day, I'm arguing with one of my engineers that the amount of just debugging stuff in the Striim server log is excessive, and I don't really like it, and we need to do something about that. So, but just going back to the database, spend a lot of time in recovery, John. I think at the time that I joined, I found that to be one of the hardest areas. Oftentimes in support, I would look at the most challenging things, and people would take a backup and they would restore it, and the database won't open. And oftentimes these support engineers would be like patching file headers and fixing checksums and stuff like that. There's like all kinds of strange utilities they had to do block edits, which are in this day and age like highly not secure. But at that time they used to do that. So that's what kind of fascinated me towards recovery. Had a good fortune of getting involved in some of the redo generation layers. So I used to own LogWriter for a long time, and it's been fascinating. What sort of that one piece of code has how it has shaped kind of my own thinking, because we went all the way from kind of logging for backup recovery purposes to physical replication purposes to high availability purposes to heterogeneous integration purposes, and now to kind of streaming intelligence purposes. So it's been fantastic. And I got to spend some time at a company called Golden Gate, which was acquired by Oracle. So got my hands dirty in not just sort of the replication technology, but also in data integration, data quality, those pieces. And then have been busy with Striim for the last decade, where we're trying to build a unified platform that brings together real-time integration, real-time replication, and real-time streaming for analytics and AI reasons. So it's been fascinating, and excited to be on the show.
Also, just great to hear how we've evolved from using logs for redo and recovery purposes on a single database. And if you take that further, you can use it for heterogeneous replication, where you can take those database logs and use it to replicate data to multiple different types of databases. Obviously, lots of challenges there that you work through, and then can also be applied for distributed compute use cases, and a lot of the address a lot of the requirements for the modern cloud analytics and now AI use cases, which we'll get into why replication is critical for model context protocol specifically. So excited to get into that. But both of you, the great part about speaking with both of you is that the amount of experience in databases and different types of databases. And I wanted to ask this first question, Shireesh, if you want to take the first one. When you think about the right database for the job in 2025, knowing all the challenges that are sort of ahead of us now, with the known unknowns and the unknown unknowns that are sort of creeping in the background, I think you see a lot of consensus towards like using, popular open source databases like Postgres, but there's also other great offerings. So I wanted to ask you, how do you advise teams to pick the right database for the job?
This is a great question, and you can think of it in two different ways. On one end, you definitely want to have unification. You don't want to have too much of fragmentation. You want to have fewer choices, and just invest in it to get it right. And then on the other hand, you want to think about best of breed and what exactly is the right tool for the right job. That approach, we may have taken it a little too far in the DBMS market, where if you think about Stack Overflow, there are around 400 databases or something like that. I don't know if the world needs 400 databases, to be frank. Now, and you mentioned Postgres. Postgres is definitely having a real moment. In 2025, honestly, it is the default answer for a huge range of apps. Developers love it. The ecosystem is thriving. And cloud providers, Azure included, of course, we've made it easier to spin up Postgres sooner, and easier to manage, easier to upgrade, and all that. So if you're building a SaaS app, prototyping quickly, and need a reliable transactional store with a vibrant sort of ecosystem in Postgres, like in the form of extensions, just use Postgres does have some meaning to it. You get good stuff, SQL standards, like different kinds of data types, all the latest and the greatest indexing, including vector indexing these days. Great community that keeps it moving forward. All the hyperscalers believe in it. So I buy that argument. Having said that, though, I will have a lot of caveats. We are, obviously, definitely want to be very clear that Microsoft believes in it. We are investing deeply. In fact, amongst the hyperscalers, we are one of the, in fact, the top committer into the Postgres source code. We've been committing quite a bit. We've been adding a lot of features in Postgres 17. We added a lot. 18. We've done quite a bit, and we'll continue to do that. But back to your point about the the right database for the right job. There are limits in terms of any engine design. Like, there's no database engine can be really designed in a way that it can capture all the workloads. And it's always been the case. It will be the case for a long time. Database design is a non-trivial exercise, so you do have to make some choices. So whenever you make those choices, you do have some gaps. There are databases like SQL Server, for instance. SQL Server is designed to be a general purpose, amazing relational database. So you could do through and through relational transactional systems, but you could also do SMP kind of workloads in SQL very well. On the other hand, there have been lots of other scenarios where you have things such as mission critical, like there's been a in memory for some time, column store for some time. There are lots of advanced security integration challenges, analytics integrations, etc. And these are some of the places where SQL really shines very well. It's optimized for compliance, high availability, advanced security features, like we have always encrypted for a while. I'm just as an example. There are lots of other QO related improvements in SQL which are really world class. So it's not necessarily just that Postgres is the only answer. Looking at the workload and deciding is important. And there are also limits in terms of how far a relational database can go. For that matter, if you are looking for something that has a world-class RPO or TO characteristics, if you want something internet scale, user-facing, then Cosmos DB is a great choice. It handles multi-region writes for sort of like RTO 0 characteristics. It has single-digit millisecond latency guarantees with a 4 nines HA guarantees in a single region, 5 nines with multi-region, lets you tune your consistencies. And there are many apps. Of course, one of the most prolific apps of the day, ChatGPT, uses Cosmos DB for that very reason. Postgres wouldn't be able to do that kind of workload. It's not just designed for that, right? So there's that. Then the final piece that I would say is that this is an important category that was quite the rage a few years ago, vector databases, right? And my view, my team's view, has always been that we don't need a separate specialized engines to do vector databases. You should be able to sort of evolve it in conjunction with your operational systems. And Postgres is a great example. It has strong vector extensions, and it covers most of all the RAG scenarios, graph RAG scenarios, without having to move the data from a transactional system to another kind of a system. So, dedicated vector databases will have their place in terms of some extreme scale or extreme design point, some exotic sort of scenarios. I'm pretty sure there is always a scenario. I don't want to say that there isn't any, but for vast majority of the enterprises, the complexity outweighs the benefits. And so, keeping them all together in one place and having fewer choices is a good way to go about. But I also don't want to subscribe to the dogma of it has to be only one or none. So both points are extreme, but I don't think there's a place for 400 different databases either.
And fast forward to that question. How is AI changing your business in terms of looking at the entire database landscape and offerings, including examples of you mentioned ChatGPT running on Cosmos DB, but other examples of how you're applying the roadmap of AI innovation to databases
in a big way, a huge way. So obviously, a few patterns that have emerged. There's a lot of frothiness in this space, clearly. So dust has to settle down a little bit, but there's clarity. There's clarity on a certain aspects. There are a few things that are still evolving. The way I think about it is that one of the best ways, simplest ways that I explain it to my teams is that there are vitamins and there are painkillers in this space. You absolutely need RAG pattern because a lot of the enterprise system of record information will be stored in operational databases, and that's never going to change, right? And LLMs are not going to be trained on those kinds of data points because those are by design confidential and private and secured, which essentially kind of comes back to the whole challenge of how do you really get the entire value of LLMs, semantic searches. Well, you have to marry the foundational knowledge of the training with that of some of the system of record sort of engagements that you typically go through operational systems, and even analytic systems or whatever, databases effectively. So RAG pattern is real, it's here to stay, and we'd have to do everything we can to really support it. The way people search data in databases is changing. So natural vector indexing and trying to, if we were to design like clause in the modern era, it wouldn't be like a regex based like clause, right? We would have done something like semantic like clause, but we ended up with cosine similarities and a very interesting looking syntax. Nonetheless, the search by meaning, not search by regex or exact predicates, etc., that's going to take off, and it's already happening. We're seeing that. And it has some really interesting implications in terms of how people think about searching their data, attaching it to their AI apps and all that stuff. And in particular, if you think about some of the major problems that databases always had, and this is kind of really where, so far what I've said, I kind of think of them as vitamins, the painkillers. And it's very important to think about the painkillers as well. The core cohort of databases, either DBAs, data developers, people who spend all their time day to day managing these enterprise really big applications, they really need to understand the database schema, need to understand the performance, they need to keep on tuning it. They cannot really, you can't design a database and forget about it, right? So how can AI really help them in their day-to-day jobs? A very classic example, that's something that we are very focused on at Microsoft, is help them chat with their query plans, right? Not just do something simple on the periphery, but go deeper and help them like solve their pain. It's not just a vitamin, it's a painkiller, right? You may have query plans that are very deep, very complex. How do you really enable them to go chat with them without having to go through all these graphic trees? You need to keep, there are many queries which the tree itself is really hard to navigate. Could you make it easy for them to, in a natural language, chat with these and go deeper depending on their expertise, depending on their problem? We're not far away from a point where these developers, DBAs, can come in and ask the question, hey, why is my database slow today? And it can give a simple answer like, hey, you're missing an index, or some, your queries have changed and this needs to happen. Or it can go all the way like, hey, I see these wait stats and these deadlocks are happening here. Maybe something's really happening. Your write patterns have changed. You go really, really deep. Or it could say that, maybe it's time for us to look at your query plans for these queries. Some things have changed here. Let's go look into it. You could go deeper and deeper, and it can be like a conversation. Doesn't have to really require some really deep expertise. So those are a few examples, and I haven't touched on many other things that you could do. You could rewrite queries to be more efficient. You could do a lot of things. You could certainly, the simple example is natural language to query language, where people want to just give you a prompt and then get just a full SQL query. Those things are real, and it's not just about the engine query, etc. It could be a cost governance, it could be sort of resiliency governance, it could be security management, etc. So AI is truly pervasive. It definitely captures all these scenarios. And on the other hand, I also want to point out again, as you were referring to, some of the biggest workloads of the day, ChatGPT, of course, it's massive. It keeps growing significantly. They all rely on our databases. In particular, ChatGPT uses Cosmos DB. All the user-facing applications of ChatGPT, every time you interact any message operationally, it goes through Cosmos DB. All the user-facing apps. We also use PostgreSQL in that space. That's sort of like the user-facing thing. I haven't even touched on how we do our development and how we think about using AI. But suffices to say that it has dramatically changed in the past several months.
Yeah, absolutely. It's changing very fast. Like that's usually the main takeaway from every episode that we have folks talk about AI, is just the rate of change is just remarkable, and something we didn't see in the 2000s or 2010s. Alok, I wanted to ask you a similar question. Obviously, we talked about vector databases a few years ago. Striim, we're focusing on database replication and data streaming, and obviously vector databases came up when there was like a hype cycle for it, and you had a similar view, which is sort of like this is more like a index type rather than a full class of databases that we need to support. So and now a few years later, we've seen that play out where vector extensions for the mainstream databases seem to be getting the lion's share of adoption there. But I also want to ask you, because by working in change data capture, getting into the logs of the databases when you truly know how the database works, so you have a unique perspective on how to choose the right database or the right job in 2025 and beyond, given all the AI transformation we're seeing.
Yeah, I mean, it's a great question, and I think Shireesh kind of covered it, fairly in detail, right? I do think that one size kind of doesn't fit all, and that's something in the database community. We've published multiple papers on that and debated it far and wide. I personally still believe that to be very true. There are some cases, John, where it makes sense to kind of invest the energy and the effort and the resources to address a very specific workload, right? But then, the other aspect of it is treating that as more of a general workload for which there is an engine. So I think databases, have come a long way. And I do think at this stage, take a vast look at, maybe largely from the customers that we interact with, how do they think about it? I think that's kind of an interesting question. On one hand, they have their legacy workloads, right? And they're sort of invested in that. And so on one hand, I think what happens is, because of that legacy investment and some of the engine choices and the feature choices that have been made maybe 20, 30 years ago, they're not able to change and evolve that very fast, right? So that's kind of like one thing that I see. So that begs the question that what do I do if I really want something fast? I want, some new type of MFA, or I want to introduce some new security level feature, which otherwise wasn't thought through in the original design and so forth. So I do see them sort of then saying, hey, how can I actually introduce these newer services and newer workloads, newer applications, but I don't have to be sort of limited to the choice that I made a while ago, right? So that introduces kind of this next aspect of my choices, which says, oh, maybe I can actually now go in and take a look at the best of breed for the stuff that I'm doing, and I'm seeing I think that a lot, right? So I think just to kind of add on to Shireesh's point, like you may think that, hey, this specific workload is best suited on Cosmos DB on Azure, right? So I'm going to actually go in, and for a lot of this data, and we've seen this in some manufacturing areas and so forth, right? They're like, this is just like sheer petabytes of data, and I want to like just push this in a scalable way. So we are seeing kind of that as the second part of it, and then there's, hey, I'm a new kind of startup, I'm a new young company. And so what are my choices? And that's where I think cost becomes also an interesting part. And I do see that many of them will naturally gravitate towards flexibility, open source, relying on the community for support. And that's where choices like Postgres make a lot of sense. And at Striim ourselves, when we had to make that choice, right, very earlier on, we said, well, let's go, and we looked at Java DB, and we looked at Postgres, right? And we started off, and then as we evolved, then customers kind of came in and said, well, look, I'm already running, one standard potentially for my mission critical workloads. Could you guys also support that, right? So then we started moving into kind of, supporting additional RDBMS engines. But we started off with Postgres. That was kind of the main point, right? I don't think there's like a one size fits all at all. I am seeing a lot of shift, I think, in terms of the movement towards newer types of engines, especially on the cloud side. I think this attitude that I'm going to manage kind of like, my own schemas and my own tables and worry about the space management, worry about kind of the backup restore part of it, I think that is becoming somewhat kind of outdated. I think I do see even very, very strict customers in the financial arena and so forth now changing their 8-9 years ago. They were like, no, we'll never get to the cloud. And now, you'd almost, that's a joke, right? I mean, I think you'd probably not be in your role very long if you have that kind of an attitude. And I think so that is a strong shift. So we are seeing a lot of workloads sort of now, either migrate or split across sort of like the legacy and the newer types of systems. So I think, again, no magic bullet here, but I do think it really depends on sort of what journey are you in at the time. That are you inheriting a workload, or are you creating a workload from scratch? To, what are the cost choices that come into play? And then finally, are the existing systems not adequate, where I need to go invent my own, right? I think so. Those are, and which are in the minority at this point, I would say. So that was a long-winded answer, but John, hopefully I addressed
Absolutely. And having the broad kind of reactive view of what's happening right now, and what changes we're going to make to support all the dynamic shifts in the market, but also kind of tying it back to, okay, databases have been around for decades and they work the way they do for a reason. I mean, it's incredibly valuable to have that perspective on top of that. So I think that's always going to be valuable for executives and engineering leaders to apply that in their thinking when they do architect their next generation applications. So speaking of next generation patterns, I'm going to ask about model context protocol, specifically for databases. Just to define it quickly, model context protocol is really a simple wrapper for LLMs to interact with APIs for either interacting with applications or retrieval from warehouses or databases. Shireesh, I wanted to ask you, what for MCP for databases specifically, what value and patterns are you seeing from early AI applications that are using it?
Yeah, so I do think that MCP has real potential to become the missing bridge between the large language models and enterprise databases. There are certain ways to get the large language models interoperate with enterprise databases, but it requires a very intentional sort of access pattern from the user without MCP. And there's just a lot of sort of repetition in terms of the implementations. So the tension has always been, how do you let an LLM understand your data structures, policies, without actually giving away the keys to the world, right? MCP solves that, and apart from all the work that you need to do, sort of every server needs to be implemented in a different way, in a unique way, in a bespoke fashion. MCP solves that by creating a standardized sort of like a policy-aware layer between the model and the databases. And instead of the model scraping schema or free-forming SQL, the server on the database side, in this case, can expose what is safe and what is sort of clear metadata information. Could be schema fragments, curated tools, whatever. They can all be put together, and they can be, most importantly, can be filtered by permissions, governance, and cost awareness. And that's important because the filter really can help you in a big way. If you kind of zone in on the security part, it's essential because the principle of least privilege can be applied to LLM database interaction. And that can safely unlock the LLM-driven apps while keeping compliance and trust and those kinds of things. So, some of the patterns that come up when I think about the AI apps using MCP with our databases. So there are a lot of folks who are thinking about policy-aware introspection. Models don't need to see the full catalog, don't even see it. They get a sort of business-friendly, least privileged kind of a view with sensitive fields masked and with row-level rules baked in so that the applications and models basically can take advantage of the data in databases safely. There's also a constrained execution. You don't want to just, instead of running anything, the model can have higher level verbs that they can get in terms of, let's say, hey, get me some customer metrics, or explain this query or whatever. The MCP server can then translate it, validate, enforce. How do you really, just give the data that the model wants? And filtering really is important. And finally, I would also say there's auditable sessions. Access is time boxed, read only by default, every action is logged, so that's also important. But just generally, the power of MCP is immense, but you need to be very careful in terms of how you're auditing it, what are the tools, etc. There have been lots of cases in the recent times where some of these LLM models, apps, etc. can go and do quite a lot of damage to your database, so you got to be very careful about it. But once you've taken care of that, then the design patterns in terms of building a semantic layer, all the easier ways that the models can give to LLMs, those are very powerful. It definitely helps them for LLMs to be deeply database aware, understand all the details without again compromising on safety or compliance. That's an important shift. Use the power carefully, but there's a lot of power here.
Absolutely. And Alok, on your side, what's really required to make model context protocol work for databases in a way that enterprises can deploy this not only with the right scale to handle their workloads and also the right governance?
Yeah, great question. And again, look, I think number one, it has significantly simplified how you're exposing, all kinds of engines now. You don't have to sort of in a proprietary way redesign every single time you're kind of working with a newer type of an application, APIs and engines, right? So MCP is super useful for that. I think in terms of databases, I think some of the things that Shireesh mentioned, right, around right from privileges and roles to kind of the access to the data itself. These are significant constructs that obviously you must address. Now, I view this as just yet one more workload, right? Like agents coming in, and then over a protocol conversationally trying to just simplify what all of us really are trying to do at the end of the day, which is, okay, you can think of it in queries and engines and query plans and optimizers, but fundamentally I'm trying to answer a few questions that currently are interesting for me for, let's say, operational analytic reasons. So the conversational style is key, right? So I do think that that's the power here. Now, as you start having conversations, we have seen this in human conversations also. Some people are super interested, really good at probing and getting information out, and some of them are not so good, right? And so with the right kind of agent, you could leak information. They could get into some of the, sort of not so protected parts of your database and cause havoc and damage. So one of the ways in which I think, just like a traditional workload, right? And you, Shireesh, mentioned the word read-only, right? So that's why I kind of went down this path. We've seen in the past where there was uncontrolled taxing of resources on a production system. And, being a database person, an easy way to address that is to say, well, why don't I actually try to have maybe a server farm where, I could have the writes being routed into one location, and then I have sort of a replica farm. As long as the latency is good enough for the questions, it's great, right? So I think that's one of the ways in which one of the patterns that's emerging or is to expose kind of a database engine, over MCP, and then so let me take that back. Database engine, with some replicas, and then now having one of the replicas being exposed over MCP to an agent. So that's kind of your first go-to. And then if something really warrants kind of an actual transaction where it's not conversation, but I'm actually making a transaction, then I think there's a rerouting back to kind of the production system. So I think that is going to be one of the interesting patterns here. Time will tell whether we'll all move in that direction. But we saw that implemented very widely globally for some of the most critical workloads. And agents kind of spawning more agents and having that kind of uncontrolled, that does put a lot of load onto the production system. So how do we mitigate against that? I think that's where kind of some of these new patterns are going to emerge. And specifically at Striim, obviously we're right in there, right? Where we're trying to say, hey, we want to make the actual intelligence that's exposed by not just one engine, but by a combination of engines simpler. And that's sort of like where we think MCP can be used to take portions of a database and then cleanse parts of it for governance and etc., and then expose that via maybe another system. And that could be a low-cost system. It doesn't have to be the same cost as the original system. And now you can actually have an interaction over MCP with that system. And this is sort of some of the ways in which you can try to protect, some of the challenges that Shireesh talked about, as well as, try to broadly just solve like a distributed replication, distributed database problem, over MCP. So that's kind of like, those are some of the early thoughts in this area.
Absolutely. And you see these patterns for real world agent deployments. And it's so clear that the key to success there is in the agent implementation, creating these deep agents that have autonomy to solve the business use case and have the right layer of indirection where you have the infrastructure to be set up to handle these deep agents and any sub agents that are created in the process to solve these problems. So, we talk about the popular use cases like customer support agents that can go query the transactional data, maybe make, like you were saying, Alok, actual transactions on the database itself, but doing that in a protected manner through read replicas, which minimizes latency and minimizes risk, because you don't want the agent implementation to be concerned about governance, right? You want the governance to be solved outside of that and let the agents do what they're going to do, but have the right guardrails to effectively protect any issues that could cause. So I do think this is one of those situations where the innovation is certainly new with model context protocol, but the patterns are very similar to having analytical read replicas, right? So the actual infrastructure that teams are going to roll out here is very similar to what how database architects have addressed this in the past. Like you said, Alok, it's yet another workload, and how would you handle another workload? Well, there's ways to do this. So very exciting. I think I think this is a much more nuanced takeaway for the listeners. I know that when model context protocol first came out, if you looked at the official docs for it, or at least one of the authoritative docs on it, I think the suggestion was just to have a read-only role for your agents on a production Postgres database, and people obviously ran into the obvious issues that could stem from that. You have to be a little bit go a little deeper into that problem to solve it effectively. So I do think the listeners can take away some really actionable design patterns from what you both shared. So thank you. I wanted to move on to Postgres and chat about that a bit more. It's always a very popular topic on this show. We've had several guests who've gone deep into really unique cloud scale Postgres implementations. Shireesh, first I wanted to ask you, I think Postgres' superpower is extensibility and the community behind it. What are some of the big architectural bets you'd like to see the community rally around in Postgres going forward?
Yeah, so I totally agree that the superpower for Postgres is definitely extensibility. It's extensibility, and you could add new data types, new indexing methods, even runtimes, and that's why it's as popular as it is today for many developers. The shadow side of that is complexity, as you said, right? It is definitely something you can end up with. You can easily end up with a patchwork of extensions in your workloads. They may not really all interoperate in the way that you want it to be in the cleanest way. And that can make it harder for Postgres to scale in production. So, to your question about what are the few things that the architecture bets that I'd like to see the community rally around. And by the way, we as Microsoft are invested deeply. We ship many extensions ourselves. But a couple of things that I'd really like to see. Firstly, I think it'd be good to see like a unified story for scale out. We have, we have few solutions and we invest in Citus. We really believe in it, etc. And we're trying to push it and make it easier for developers to shard, not just on the a row level or a table level, even schema level. So we have different kinds of abilities to shard, but having a native consistent way to scale a workload out would really make Postgres the vision of sort of being a default database or whatever. I mean, again, I don't believe in being a default database, but to the extent that developers want to keep it as a default for most scenarios, that idea of unified scale out, and I know different people have taken different paths here. So that's that's really important, I would say. The second thing, back to extensions, I do think that standardizing the packaging and lifecycling. I know there's work that's happening here, but installing and upgrading extensions, it's a bit of Wild West. If there is a way that the community could converge on a model where extensions are like clearly versioned, certified, they play all well together, that'll help the community. It will definitely unlock confidence for enterprises. You're looking at adopting Postgres. It's one of the challenges, right? So you could really go solve that. And then I would say, the third one, I think there's a lot of work on AI primitives in Postgres, but I would love to see like them done in the Postgres way, in a native way. And this is where we are definitely leaning in terms of bringing in some of the cool things like disknn. I know there's PG vector extensions, which is very popular, but things around vector search, embeddings, retrievals, etc. I think the community needs to spend a little bit more time on agreeing on standard operators, indexing strategies, governance, and how they really operate with the runtime capabilities outside. There are a lot of competing sort of ways to do a few things, and it needs to be deeply thought through. More love is needed there. I think those are a few things. Maybe finally I would just add one more. I think operability as a first class concern is an important thing for Postgres, given the amount of engagement that it is seeing, the workload isolation, resource governance. Those are the kinds of things that are really important when you are trying to deploy this in at scale, especially in cloud. The core and the extension ecosystem, they need to embrace this thing natively. I think that'll really go a long way. It'll reduce the cognitive load for anybody running at scale. So Postgres has already won on extensibility. I don't think there's nobody debating about it. But I think the next frontier, I would say, is about coherence, is about really making sure that you scale it up to the enterprise grade, think about operability deeply, and make AI first class instance, and make the extensions more certifiable, extensible, and that kind of stuff. The community is just it's a brilliant community. They care about all these pieces very well, deeply, and we are here at Microsoft certainly engaging with them, contributing. We do have very deeply vetted, deeply embedded sort of contributors and committers as part of our team. And we are very engaged, and we look forward to partnering with the community towards these goals.
Absolutely. And that's one of the most powerful parts is, through community, you get standards and you have less, duplicative problem solving between companies. And Alok, I wanted to ask you, you're also working deeply with Postgres through Striim and database modernization and innovation projects. What have you seen in terms of scale and adoption of Postgres for particular enterprise use cases?
From a horizontal perspective, I think we're seeing a lot of adoption of Postgres. And let me just clarify what I mean by horizontal, because I mean, with specifically you guys, it can mean one thing if you're in at the engine level versus sort of like a general level. What I mean by that is broadly from an adoption perspective, as folks are thinking about adopting AI and analytics and newer workloads, they are thinking of splitting up a lot of their existing workloads and applications. So there's this whole journey to get to that cloud. And what we are seeing is, number one, the question that I get asked most often is, hey, look, right now I'm running this on like a massive Oracle RAC cluster. Is Postgres, is it mature, right? Is it going to be able to actually scale to these workloads that I'm running this very, very mission critical application on, right? And awkward question for me, because I don't want to take a stance. Ultimately, I am. But we are seeing that question come up more and more. And I do think that some of the very, very large enterprises are making that bet, especially with the hyperscalers, right? Especially when they have their own flavor of Postgres, because then I think they do realize that, hey, if there's something is not up to what they need in terms of SLAs, in terms of their roadmap for the future, they can go in and hold somebody accountable for that, right? So that, I think we are seeing a shift there. Now, in terms of the adoption of Postgres, I can tell you at Striim specifically, I mean, we've had massive implementations where we've done, literally within a few weeks, thousands of actual migrations into Postgres from, on-premise types of systems. And these are not sort of lift and shift migrations, mind you, right? These are actual, what I call zero downtime live type of migrations, oftentimes with bidirectional links being set up, because you don't want to give up on an existing on-premise system. You want to actually have a way to move over and pull the plug at your own, leisure, if so to speak, right? You don't want to say, hey, I'm going to keep my entire partner community, user community hostage and December 31st at midnight and hope for the best, right? That, I think those days are a little bit tough to swallow nowadays. So we are seeing that adoption. The other piece that also we are seeing is sort of this from the cloud to maintaining, and this is largely cost reasons as well as some SLA concerns, where we are seeing a reverse flow of limited portions of that data into what I call managed systems in Postgres that customers are managing themselves. So that's where they could have a version that now they're maintaining, but they just want to have that for maybe, let's say, in a geographically distributed retail system, it could be per online store. There's a Postgres that's running. And so they do want the reverse flow also coming in. And if to that degree, I mean, this sort of should sound familiar to your audience, going back to maybe operational to data warehouses to data mart type of a pattern. Now we're seeing sort of like this, legacy to cloud to sort of back, which is sort of like this. It's not quite a data mart, but I would say it's a data product, right? Where a team wants to actually get portions of that data, but they don't want to necessarily hit just the core system on the cloud. And that's where, again, from a scale perspective, literally I've seen single customers adopt 10 to 15,000 Postgres databases, and they're pushing data from the cloud-based systems onto these self-managed Postgres systems. So I think it has and Postgres has come a long way, right? From I mean, Shireesh would know better. I think from version 9 till now 17, 18 coming up and so forth. I think they've caught up on partitioning and on replication, on security, on just developer productivity, supporting basic operations like upserts and merges and all kinds of JSON-B data types and the vector types. So I think they've made a lot of progress. But I do think I want to pick up on one point that Shireesh made, which is on the mission critical part of it. I think customers do have concerns there right now, where the automated part of, for example, maybe just moving over from a primary to switching over to a standby and back, or having like a cascading system where I do move to a standby, but then all the workloads that were relying on the primary get adequate notification and it's seamless. I mean, and I personally deal with, for example, Postgres replication slots, right? So I was very happy to see failover slots, so that at least you don't have to reinstantiate. If you just go to a standby, you're able to take advantage of that. I was happy to see that there's support in these decoding layers for more than 1 gigabyte of redo for if a transaction spans that. So I think we've come a long way, and the future seems very bright, and customers are super interested in it. That's sort of my take on Postgres.
I always think that's a very important perspective for engineers and leaders to hear, because I think there's sort of two sides of the coin of, hey, you can try Postgres either in a lab or if you're an early stage startup scaling incrementally, over the span of a year. That's completely different from an enterprise migrating an existing production workload that touches thousands of employees and millions of customers with lots of revenue on the line and lots of business risk, and then migrating to a completely new database there. So like the risk calculus is completely different, but it's also very promising to hear that there's certainly adoption and examples of wins and maturity there. So I want to ask about modernization broadly, and maybe Shireesh, we can start with you here. So for teams that are modernizing data applications on Azure specifically, what's your practical playbook for success?
Yeah, it's a great question. At Microsoft, we basically we definitely have a lot of evidence and starting to see a developer story emerge around the Azure AI, and it comes down to unifying 3 levels that I think used to be separate for a long time. There is a developer experience that we go after with Copilots and VS Code. There is the data foundation, which is where Fabric and Azure databases, Microsoft Fabric and Azure databases play. And then there's an application runtime in between the developer experience and the data foundation, which is basically what we have with Foundry for agents and AI workflows. So that's sort of like the 3-piece stack of Microsoft that we go with, and that's the the stack. Like there's a developer experience on top, application runtime, and then there is a data foundation. So that combination is powerful. Developers don't have to juggle like multiple tools anymore. They can just open the VS Code, use copilots to design prompts, queries, or really go deeper if you are a pro developer, or you could use like GitHub Spark for like, just getting started with Vibe apps. And then you get powerful extensions where you can see the data governed right there. You could push to production easily. You could monitor, but you have all these key pieces from Foundry coming in to make that stack really, really helpful. Now, if you're a team modernizing data apps on Azure, specifically, since that's your question, the playbook that I would generally use is like a couple of steps. The first step I would say is like, think about the developer UX. You obviously tools. You got to start there, and you really make it easy. And in the world where there are so many tools to do a lot of these things, it's really important to standardize on a few things. I would suggest VS Code, GitHub Copilot, Azure AI extensions, and such. These are very well proven. The developers should test prompts, build workflows, debug database interactions in the IDEs, get confidence, because it kind of really helps them. They have to get familiarized because it's a new era for everyone. It's like, honestly, 99% of the developers haven't ever built workflows in this way. So you have to lower the barriers and build the momentum quickly. So betting on some of these tools like VS Code, GitHub Copilot, AI extensions in Azure, etc., really good starting point. The step two, I would say, is like you bake in your operational guardrails, and this is like data in specific. I would say this is where like Fabric, Azure databases with built-in governance, row-level security, workload, all those things, wrapping it with Azure policy, etc., comes really handy. Every AI-generated query, you got to have a very clear path. What is the MCP strategy, or what is the governance strategy, what is the observability, etc. So those guardrails need to be very clearly defined, rate limiting, from day one, for instance. So that is a step two, I would say. Then the step three, I would say, is that you got to choose your workload wins that prove the point before you really go and scale. And this is perhaps one of the most important mistakes that most of the customers do. You want to like really get something going, a clear pain point that you can go build, and then establish your playbook. We do see patterns like copilots for analytics teams that accelerate SQL and BI and Fabric, agentic style apps in Foundry that automate things like customer support, IT ops, etc., with clear SLAs. High volume, cost sensitive queries for databases. These are all few workloads that you could get going with, right? You sort of like win them, prove a point, and then scale about it. So I think the net effect that I'm trying to say here is that developers stay in their flow. Ops need to get the guardrails that they want. And then on the other hand, business leaders want to see a quick proof of performance, cost saving, reliability. You could totally achieve these three things that I touched on: the developers, the ops, and the business leaders. So I think this is kind of really the playbook that I generally discuss with many of our customers. Then you can go from experimentation to true modernization on Azure at a large scale. So we got all the tools, we have all the things that you need at every step of the way. But being very clear about the stack and then going in these orders can really simplify. I think that's a good playbook in my mind.
Alok, I wanted to ask you specifically, we work with so many companies that look at the data foundations that Shireesh mentioned in the modernization process. What's your recommendation and advice strategies to leaders who are going through major modernization?
I mean, I think from my perspective, I think the last point, right, about business leaders trying to do it piecemeal is very important. Because often I think that they could take sort of like a hey, let's just do this thing, and then if something doesn't work, then they start re-questioning and going back and saying, hey, was this the right choice or not? So, and I've seen multiple folks be successful, large companies that have literally 50 to 100,000 databases be successful in this, is by identifying workloads that could take advantage of some of the capabilities, let's say, on the cloud, either services or infrastructure, storage, compute, elasticity, scale. So then the question is like, what do we do with the data, right? So I think it's key to make sure that if you're trying to deliver a new contained workload in the cloud, you identify sort of like, hey, what is that workload, number one, and second, what is the data that you're going to need? And that's where at least my conversations start, right? That we're giving a lot of choice to these businesses to say, look, you could actually take subsets of this data and safely go in and try out and test out the newer service, the new platform, the new infrastructure, storage system, compute, whatever choices you've made, but still allow your workloads to run there and see whether they meet your requirements and your SLAs or not. And I think that is what the modernization journey looks like, to me, right? Because I would recommend that oftentimes if you do a lift and shift, I think it works for test and dev type of workloads. It may work fine, but for production, it's a little risky. And shutting down a business in sort of like 24/7 global economies is no longer an option. So what that looks like is to have a sort of a proper testing methodology towards getting there. And I think loosely, like to be very specific, you could just think of this as either database or platform modernization or application modernization, and then having a path to that by saying, I'm going to actually keep maybe concurrent systems, and then that gives me that choice. So I think that should be a key part of this. Along the way, I think what we do see in modernization is a tool set that's needed, because rarely do we see people say, okay, I'm running a workload, I'm just going to go lift and shift and run it somewhere else. They do want to take advantage along the same time to say, hey, all these choices we made 15, 20 years ago, maybe there was not instant alerting available at that time, based on some trigger. I do want to address that in my newer system. So along the way, do I want to actually now revisit some of the design choices for potentially my schemas? Do I want to go in and denormalize certain things or normalize certain things along the way, right? And so now you're introducing sort of like the requirements for a tool set that allows you to address this in more of a comprehensive manner, rather than, hey, leave it up to individual developers to kind of go in and do that. So number one, introducing those changes. Number two, tracking the state of those changes and the metadata around that, so you're aware that, hey, there are multiple systems involved, but they are running with different types of configurations, but somebody knows about it, and that's queryable. So that's kind of like one part of the modernization that kind of comes in here as well. So I think those are two key pieces, and it gives you, at least from the Striim side, I'll tell you that as we've revisited this, the modernization journey, we've also seen customers say, well, look, I am actually doing a lot of, what I call instant dynamic alerting, dynamic decisioning through polls, right? And so there's this ability to introduce that in the path, especially if this is going to be a multi-year journey, right? So then if you sort of put that in the path, in the pipeline, that's where you sort of add this whole modernization intelligence to the whole system, where you're saying, you're getting into now some of the interesting concepts, like the difference between historical deep analytics versus streaming real-time analytics, doing alerting based on push-based events as opposed to poll-based events. So that's also part of modernization, because if you take a look at the consumers today, right? If you talk to anybody who's under 20, they don't quite understand this concept of getting an email the next day, and they almost laugh at it, right? And we laugh at it too. And that's what it is, because you're seeing, some devices where people are dynamically saying, oh, let's change this route, order this, get my food delivered by the time I'm there, my Uber is there. That is the mindset. And so I think there's a great opportunity to modernize if you also are trying to say, let's take advantage of these newer types of consumer-oriented aspects within my modernization journey. So long-winded thing. So I would say that there are 4 phases here. There's sort of like hey, I just want to adopt the cloud and I want to just like migrate to the cloud. Then there's, hey, I want to, along the way, re-platform certain things, right? Redesign certain things. Then there's the third piece, which is, hey, can I revisit some of the choices I'm making in terms of, where am I doing my analytics? And the fourth one, obviously, is like, hey, the readiness towards, hey, the AI workload in the cloud. So what's needed for that? And I didn't touch on that earlier, but an example of that would be, if I have a lot of unstructured document I've collected over the last 30 years as a healthcare organization, maybe it's a perfect time to actually create vector embeddings and stick them into the newer system so that the AI services can take advantage of that through semantic searches and so forth, through RAG patterns. And I think that is what the modernization journey should look like, those 4 pieces, in my view.
I know we mentioned vector indexes a couple times. It is a lot more powerful than people give it credit for. It is almost magic. I mean, my anecdotal experience is it's always been sort of this magical thing that allows you to interface with data in ways you didn't imagine possible. You know, I know it's comparable to search and I-like and regex based matching, but it can really be powerful when you lean into its capabilities for classification and summarization, sentiment analysis, things along those lines. So like, and I think it is good advice, like, whether you're, an enterprise that's taking this, 20-year-old militarized on-prem database that can't connect to anything, it just runs its workload. Now you're moving into the cloud. As you're going through that journey, yes, think like, what's the art of the possible here? Because now this database can scale horizontally, and I have VS Code and Copilot and all these amazing developer tools to do so much more with the rich operational data that this database is handling in real time, right? Through embeddings or streaming analytics or AI agents with MCP. And it's good to kind of get ahead of that both in the migration process and the modernization design and what the future looks like, because the main thing you get there is just speed of execution and getting the ROI of the modernization so much faster, rather than just saying, hey, we were doing this on-prem, now we're doing it in the cloud, and almost like an apples to apples comparison. It's really a lot more powerful than a lot of companies can imagine, in addition to getting a much better developer experience and internal velocity. So definitely great advice there. And then, for companies that are already in the cloud, I still see this sort of, segregation between like the operational database workloads and then the analytical AI workloads. And I think it was really great talking to both of you about this, because they really have to be converged. I mean, I think the magic is really when you combine the operational workloads with the AI, and we're just scraping the surface of agents. And Shireesh, like you said as well, MCP is sort of the bridge between these AI agents, these deep agents that have autonomy and can solve problems with tools, and get them to interact with the rich operational data, whether it's the customer data, the user-facing application, and get the full value there, because that's how companies go from having and Alok, you elaborated on this too, like the modern experiences that people expect, whether it's a chat interface, because chat is taking over user experience in so many applications. Taking your legacy application, which might have been built in 2018, just like 5-6 years ago, and turning it into an AI native application. I think that's where engineering leaders, executives really have to look at combining the database with the AI.
Yeah, and maybe John, I'll add one quick thing, which is we're working on some interesting stuff that has to do with governance and validation and so forth. And this is my personal request to Shireesh also, so we can actually think about. So one of the things is that imagine that these systems are SQL and Postgres and Cosmos DB, right? And there are subsets of data that are supposed to be identical. So one of the interesting things is, we have this validation capability now that we're adding to say, go in and compare these things. But I don't want to stop there, right? I want, Shireesh, you to expose some, engine or MCP, but I can also say, hey, these things don't look the same. Were you doing were you responsible for replication between these systems? And if so, can you tell me about these keys? Like, when was the last time you had visibility about this stuff, right? So this is truly now taking sort of like this isolated transactional view within the context of one system to conversationally sort of going across these multiple agents and truly trying to answer these kinds of questions, which are super interesting for forensics and troubleshooting and debugging and all of these things that our engineers spend so much time on today.
Absolutely.
Yeah, so I think I'm really excited about that.
No, especially on the cyber tech, for instance, these kinds of questions really matter a lot.
Yeah, absolutely.
Cybersecurity, I meant to say. Yeah.
Shireesh Thota, Alok Pareek, thank you so much for joining this episode of What's New in Data. I think it's extremely valuable for all the listeners today. So thank you for generously sharing all your insights and experience and what you're seeing through the work you're both embarking on right now, working with all these very innovative, scaled out companies launching their next generation applications. So thank you so much for joining.
Oh, thank you. Thank you, John. Thank you, Alok, for giving me this opportunity to join you guys today. I really enjoyed going deeper, talking about many of these technical aspects. It's an exciting time, and I'm once again thankful for giving me this opportunity to talk to you all.
Yeah, and thank you, John, again for having me. And Shireesh, it was a pleasure. Thank you, and I look forward to multiple future conversations with both of you guys. Thanks.